Our job today here is to write equations of lines. Now, if you were here with me and I asked you what is the equation of a line, probably 99% of you would say y equals mx plus b. And you probably say it like with a little cheerleader attitude because it's been drilled into your head pretty well. So y equals mx plus b. But this lesson is about a different way to write the equation of a line called the point-slope form. And really, I like this way a lot better. I think this is a whole lot easier. And with a little practice, you might agree with me. So let's see how it works. What it says is that if we have a line that contains a point, and so our point will be specified for us as an x and a y coordinate pair. And we also have a slope identified. And that slope, just like in y equals mx plus b, the slope is going to be m. Then we can write the equation, this is the point-slope form, and it looks like this. It's going to take y equals the m, or the slope value, multiplied by x minus our x1. In other words, x minus our x-coordinate. So we're going to pull that right out of our point value. And then outside of the parentheses, we'll add on the y-coordinate. So our x-coordinate and our y-coordinate go here and here. And that is the equation of the line. There's nothing extra to do. You don't have to solve for x or find the b or anything. That's the equation of the line. So let's see how it works in this example. We're going to write the equation in point-slope form. So we have to read our directions. And that's going to look like y equals whatever our m is times, in parentheses, x minus our x-coordinate. And then we add on our y-coordinate at the end. So with the particular numbers we have here, our x-coordinate is 5 with y is 4. And then our slope is -9. So if I'm writing this equation, I'm just going to write y equals, in for the slope goes my -9. Then in parentheses, I've got x minus my x-coordinate, that's 5. And then I add on my y-coordinate on the outside. So take a look. Here I've got my slope, my -9 slope. And I've got my x-coordinate and y-coordinate plugged in straight from the point. X was the 5 and y was the 4. And so that is my answer right there. Y equals -9 times the quantity x minus 5 plus 4. And that's all you got to do. Let's try it on this one. Again, it's going to be y equals our slope times x minus x1 plus y1. And I'm only writing this over and over just to help you see it again. But really, in practice, you can go straight from the question straight to the answer. So here we go. Y equals, in for the slope, we put our 3/5. Then in parentheses, it's x minus x1. X1 is 8, so it's x minus -8. So we're going to actually change that to +8. Let me make that really clear. This is +8. Hopefully that's really clear. And then add on the y value. So tack on the +3 at the outside, and there's your answer. Okay, let's see if we can do this one without writing the formula first. It's y equals the slope number, -8/3, then in parentheses, x minus the -18, our x-coordinate. Let's make that say x plus 18, and then bring down that y as -2. There's your answer. Try this one. Pause the video, come back, see how you did. I'm going to let you give it a shot. Okay, look it over. How does it look? Do you have the same thing I've got? Is your slope of 1/2 sitting right here in front of the parentheses? And is your 9 inside the parentheses being subtracted from the x, and your -1's out here on the outside? How'd you do? Hopefully that went well. Now they get a little more challenging. Here we see an example where we don't know the slope, but we know 2 points instead. And so our job is going to be first, we can't do this without the slope. So we got to figure out the slope, and we'll review. That's what we've been doing with this whole unit. Let's do a point stack and take that 10, -3. And stack it with the 4, -5, and let's just subtract and find our rise and run numbers. 10 minus 4, that's a 6, and then -3 plus 5. -3 plus 5 is 2. So rise is 2, run is 6. Our slope value is going to be 2/6. Now don't leave it like that. That reduces, so let's divide that by 2. And that's going to bring us down to a 1/6 divided by 2 is 3. All right, so that's our slope. And then we need a point. Well, we're lucky because we have 2 to choose from, so we get to pick. It doesn't make any difference which one we pick. I'm going to pick the first one here in the list to use, and I'm going to write my equation. So here we go. It's going to go y equals, what's our slope? Y equals 1/3 slope times, in parentheses, the x minus our x-coordinate. We chose 10, and then add on the y-coordinate. There it is. Now, had we picked the other point, we would have come up with different numbers right here, but in a graph and an equation, it's the same line. So we can use them the same way. So we'll take this answer. Okay, you try this one. Give this one a shot. Again, it's like this. You're going to have to do a point stack and figure out your slope, and then you choose a point and come up with an equation for that line. Come back to me in a minute after you have that done. All right, here's what I got. I actually did it for both points, so it depends on which point you picked. Did you get the same slope I did? Here's my point stack, and this is what I came up with for the slope number, just 4, positive 4. Here is my equation if you choose the point of negative 1, 1. So you're going to get the y equals 4 from the slope, then x is going to be plus 1, because our signs changed when we put in that negative, negative, and then our y is plus 1 out on the outside. Now, if you pick the 0, 5 point, then this is the same, this is the line you would get here. Why don't I have a minus 0 in there? Well, if I wrote minus 0, it would just be the same thing as just doing nothing. So I just left it as an x. And that's the cool part. All right, in 7, we get to graph. Or we actually get to see the graph, and we're going to write the equation. On this graph, I have a couple of points. Let's just pick one of them. So I'm going to pick point, let's just take point A and read its coordinates from that. It looks like it's tiny, but it looks like it's at 3 and 8. So let's use that, 3, 8. And then for our slope, let's do our count, our rise and run count. So let's come from B, clear up here to that level, and then over to A. And if I'm counting that, I'm seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a positive 15 rise. Coming across, 1, 2, 3, 4, 5, a positive 5 run. So for the slope, let's put those together. Call that 15 over 5, and let's reduce that. 15 over 5 reduces just down to 3. So 3 is our slope. All right, time to write the equation in point slope form again. So let's go y is equal to, plug in your slope, 3. Then in parentheses, take x minus your x coordinate, so x minus 3, and add your y coordinate of 8. And you're done. Okay, here's one for you. Number 8, so try this for you. Come back and compare your answers with mine. Okay, let's check your results. I built my slope triangle, a rise of -2, run of 10, and that does reduce if we divide both by 2, and that gives me a -1/5 slope. So depending on which point you picked, point P's coordinates here, that gives you this equation if you chose point P. And if you chose point Q, then you've got this equation for that final point slope equation. So either one of those is right. Let's pause for a second and take a look at the slope-intercept form that you're used to and compare it to the point slope form. So your old friend y equals mx plus b. We still find our slope here, but this b value, of course, that's our y-intercept. And there's our slope. And when we compare that to the point slope form with y equals m times our x minus x1 plus y1, probably the biggest difference between these is all of the length of this. This is what most people would consider simplified, and that's why you learn that one first. Where this one's not, but it still gives you information. So if we want to take our point slope form and we just want to do a quick simplify, that's a fast way to get to our slope-intercept form. Let me show you what I mean. We're going to find the equation of this line straightforward with the point and the slope, and then we're going to just change it, transform it into the slope-intercept form that we all know. So it contains this point, just like on the front. We're going to go y equals, plug that slope in, and then plug the point values in. It's x minus that -8, so we'll make it plus 8, then bring down the 3 as a plus 3. That's our point slope form. We need our answer in slope-intercept form. So to do that, all I do is I simply just distribute and get rid of the parentheses and add the 3 on at the end. So if I take the half and multiply it through by the x, then I'm going to have y equals 1/2 x, bring that half and multiply it by the 8. Half of 8 is 4, and then just bring down the 3. So that got rid of the parentheses, and now my last step is just to combine my like terms. I still have a half x, but 4 plus 3 combined to make 7. So this is the slope-intercept form. You can see the slope is still 1/2, but the y-intercept, if we needed it on a graph or something, would be 7. Okay, new example. Same thing though. Let's turn it into slope-intercept form, but let's start with the original point slope form. Y equals, what's the slope here? -5, parentheses x minus your x coordinate. Since that's -2, I'm going to put x plus 2 and bring down the y coordinate of +9. Now let's convert that into the slope-intercept form. Let's multiply that -5 through. So we'll make this say y equals -5x plus -10 as I multiply those together, and then bring down that +9. Then I'll just simply combine those like terms. Y equals -5x, -10 and 9 add together and make a -1. There's my slope-intercept form. Okay, now we're going to up the ante here. We've got 2 points. We have to figure out the slope. Take the 2 points. Let's make a point stack, 6 and -3, 10 and 5. Let's figure out the slope from these by subtracting. 6 minus 10 is -4, and -3 minus 5 is -8. Let's put the rise over the run. So I'm going to take -8 over -4. That's a simplify. That's going to become positive, and 8 divided by 4 makes 2. So +2 is my slope. Okay, now that that's done, let's take the point slope formula. Y equals, what's our slope? It's 2 times x minus, let's just take this first point, x minus 6, and then tack on the -3. Okay, so I am going to just simplify now, put it into slope-intercept form. Y equals, bring the 2 through the parentheses, so it's 2x and -12. And -3 combines down to y equals 2x minus, looks like 15. There's our answer. Now I do want to show you something. I want to show you that even though we picked the first point, we would get the same line had we picked the second point. So I've got a little space here. I want to just show you that I get the same result if I pick the second point. If I take y equals that same 2 slope and then plugging in the 10 and the 5, so x minus 10, then plus 5, when I bring this out and simplify it, look what happens. It's 2x and -10. So 2x, -20, 2x minus 20 and then plus 5. And when you combine that 20 and 5, that -20 and 5, you're going to get y equals 2x minus 15. And notice that's the same thing we got when we chose the other point. I think that's awesome. I love that part of math. All right, last example and then some try these for you. Let's pull the slope off of the graph. We always need the slope of the line. Counting this out, I'm looking at a negative rise number and then a positive run. 1, 2, 3, 4, 5, 6, 8, 9. Looks like -10 as my rise. What do you get for the run? I get 6 for the run. Do you? Okay, so let's build a slope equation putting that -10 over the 6, and then let's simplify that to -5/3. So the slope's -5/3 that we'll use. Okay, pick any point you want. How about G? Let's just use this one. So G has coordinates of -3, 7. So let's use this slope and this point. Let's build our equation. It's y is equal to the slope first, -5/3, and then in parentheses x minus the -3, so that's going to be x plus 3, and bring down that y plus 7. Multiply through, let's put this in slope-intercept form. Y is equal to -5/3 times the x, and -5/3 times 3. That 3 is going to cancel this one, so that's just going to leave me a -5. And then I bring down that 7. Final answer, y equals -5/3 plus 2. There's my answer. Now before we leave this and you try these on your own, just want to point this out. The y-intercept is 2. That's the slope-intercept form. Where does this line cross the y-axis? Check it out, at 2, just like our line says.